Right. So the first part of today's session, as I told you earlier, like I would like the text classification problem. So simply we will look at like how you may use text data for putting into categories or as a classification problem. So there are various different of application you can think of. For example, email classification, news classification, web pages into subject categories, research papers into categories, and so on. There are a lot of applications that we can talk about in when it comes to text representation. But if you look at how we can use machine learning to automate text classification, that means we focus on building classifiers based on classifying text documents. So ideally, we have to have a set of training data or example documents with labels, and then we can build the model to make a predictive model. But the first crucial task that I want to discuss in today's session is how do you represent these documents or the text. Why I say that if you take a text document like this one, it has quite a lot of you know data in different forms. Like for example, in this web page, you can see there are like headings, timestamps, a key image, some highlights, and so on. So there are a lot of information. And then we already know from a basic machine learning background, what you need is you need a set of data in a matrix form. So a document like this, how do you put into matrix form? That's exactly what I want to discuss. And if you look at the document perspective, you have different things. You have text, you have structure, you have facts, you have layout, and so on. So how do you convert into matrix form? That's the key issue that I would like to discuss. So let me introduce the very basic one. It's called bag of words representation. And in bag of words, what happens? Simply we use words and without considering their order. So you can consider order if you want to represent, but in this particular case, we compare just words without any order. So let me give an example. So let's say we have three documents. Simply the documents I'm going to represent using just one-liners where we have three simple statements. So ideally, the simple bag of word representation would be like something similar to this. You have the set of words and then the documents. So how do you represent them? So the first one is the dog sat on the floor. So you can see that you can write down the numbers. So we can say, okay, the dog, we can say, okay, dog sat on the dog, right? Say so you can have two. So maybe we can write. So I'm just okay. The dog sat on the floor. So that's the first one. So all the other words we can say zero. So this is like we use word frequency. That's one way of representing in bag of words. Or the other one is you can just use 1 and 0, right? Which says that whether the word is there or not. So that's a first or simple way of representing this one. Secondly, if you look at the second one, it says the man sat on the floor. Again, like the man, so the again it's appeared twice. The man again sat on the floor, right? So now this time dog is no, his is 0, walk. So that's simple representation. Again, third one, if you look at the man walk his dog, we can say the man walked, right? The floor. Sorry, in this particular case, the man walked his dog. The man walked his dog. So you see the simple representation. So that's a very simple one. There are other smart ones which I will discuss later on. For example, use of TF-IDF, which is called term frequency and inverse document frequency. So that I will discuss. For the time being, let's start with this. So let's. So now I think you understand this very simple representation. Although you see that this is very simple representation, this is quite challenging because you see what we have discussed is a very toy problem. So the documents were just one sentence, and we use the word as it is. And imagine like when you have large documents, the vocabulary will be the words in for example English language, which would be huge, right, compared to the document sometimes. And there will be a lot of zeros, although you don't see zeros here, right? Actually, if you use generalized words, then there will be a lot of zeros. We call sparse data. So learning from this will be very, very challenging, right? So with that said, if we continue my discussion, there are a few things that you have to understand as well. So let me quickly go through those pre-processing steps as well. The first one is word frequencies. We already know some of the ideas, like, for example, things like articles, some of the words appear everywhere. And these are not very interesting. That means the term frequency is really, really high. They are not very important. At the same time, if it is not very frequent, that is also a problem because it rarely appears in the document. What we need is something in between, right? So you have to actually discard some of the most frequent ones, at the same time, most infrequent ones, I would say, right? So that's something you need to consider when you talk about the words. Secondly, the common ones I told you, like usually we known as stop words, and then there are different ways that you can actually remove them. So commonly there are some common stop word list which you can use to remove them. Again, they don't contain any information. Next, there could be stemmers. There are different word forms are there. And the idea is you have to get back to the base word, right? Like house, houses, health, healthy, you have to use them. There are two techniques are available. One thing, stemming, the other one is lemmatizing. So here it says stemming, that you remove the suffixes. For example, house and houses, you remove the last S. So likewise, you can actually remove part of the word, which you call the stemming. The common program, common stemmers used for English language is like quarter stemmers. The rule-based system which uses to remove the suffixes and sometimes the prefixes to get the root of the word. Now, once you have removed them and once you get them as very important ones, then these are considered as the words. So we can say these are the very important one. We say, okay, they are the index terms. Now, there are other things that we also need to consider. Although we think that just one is a feature, right? That's the basic, or that's the straightforward implementation. There are other things. Sometimes multiple words appears together. Like if you take the word like in front of, you have three words, but commonly these three words work as a phrase. So when we represent, it's ideal to take these three as a just single unit, right? So you have to focus on the phrases as well. Then there are n-grammars. What do you mean by n-grams? So for example, if you take one word at a time, we call unigram. You take each individual word at a time. And then you can talk about bigrams. You take 2 words at a time, 3 words at a time, n words at a time in general, right? So these are like some of the ideas that actually sometimes think about when you think about the terms. So whether you are going to use 1 word, 2 words, 3 words, it totally depends on your design. Right. Now that we have an understanding about the index terms, let's quickly look at whole pre-processing step. The ideally you start with all the text contain. We have some what you call the other characters, different capitalizations, emojis. Sometimes you have everything. Right. Ideally, the second step would be that you remove any unnecessary characters and maybe you just take the text. And ideally, you can convert into uppercase or lowercase. Then you remove any stop words like articles like the. Then you can use stemming or lemmatizing. I have used two. Stemming means you remove part of the word. This last one, lemmatization, means just a one-to-one mapping, that you map a word into its basic root form. For example, if I say went, right? Ideally, using lemmatization, we can identify the root word or the base word for went as go, right? And finally, those are the terms we use as features, right? So there are many ways that you can use, and then there are many data sources, different data types, and each of these you have to make pre-processing. So ideally Python, since we are using Python has a plenty of libraries, or intuitively it can be used to pre-process the data. So I have listed some of them. So how you may use different types of data sources, and then you have to clean and get ready for that, right? That's the usually what will happen in text classification problems, right? Now, one of the assignments that I want you to give from this today, I will discuss the first part of this, and I will release you the training data set. So the ideally, you actually use this to pre-process and then representing it as a matrix form, so that you can actually apply for the algorithms we have discussed so far. So ideally, I want you to select one of your favorite machine learning algorithm to build a classifier. At the later stage, I will also release a test set where you are going to use that test set and you are going to make predictions. And actually, I have the labels, and let's see how far you can go with this one. Right. So let me show you the data format. So I will share in a minute like the data. So the training data set, you have a 200 training data points, and test data set, we have 100 data points. And ideally, it's a text form where it uses tab character to separate the data. So basically you have 4 fields: class, title, date, and body. And the class is either +1 or -1, just to indicate it's a two class problem. Right. So I told you this is a binary problem, and positive example, the instance label with plus, it's look like this. So I told you like there are 3 parts. You have class, title, date, and body. Title, date, and body is everything in one single example. Similarly, a negative example, which is again the same. So the idea is you build a model to predict whether when you're given a text, whether it's belong to a positive category or negative category is the question. Right. Okay, I'll have some links. So then I'll share them later on. Okay, I think we are good to go. So let's see how to start with that one. Right. So I'm going to share my Colab notebook. Right. Shall we start there then? Okay. So let's start the pre-processing part. Let me explain some of the ideas we discussed. So under this one, I'm going to explain how you may actually pre-process text and various other things that we have discussed, right? Okay. First of all, let me show you bag of word representation. So we are going to discuss bag of words, um, or we can say bag of words representation. Right. So let's put up all our three statements. So I'm going to say it's as input, and then I'm going to have a list of three words. So the three words we have used, the dog sat on the floor. So this is, I'm going to take it as a first step. The man sat on the floor. And the third one is the man walked his dog. So let me say this is my input. Now, in scikit-learn, we have something called count vectorizer. So the count vectorizer is the use. We can, if you read the documentation, you will notice that this will convert text documents into what we call the matrix of tokens. Ideally, you have set of documents, and then you are going to convert into words and then documents. Right. So you can have representation here as well. So let me explain with my example. So let's use the word. We have to say from sklearn. Extraction, and then we use text import count vectorizer. Right. Now, so how to use is the transformation. So I will say, I'm going to create the transformation. I'm going to say vectorizer. And what I'm going to use the method count vectorizer. Right. And then we need to transform our input to this one. So we are going to fitting in. So the second one is we say vectorizer and then fit input. Ideally, we input our data and using count vectorizer, we convert into matrix form, right? So before I show you the transformation, let me show you the vocabulary. So vocabulary, we can say, this will create something called vectorizer dot vocabulary, vectorizer vocabulary. Right. So let me run and show you. So first of all, when you say vocabulary, this will list the number of words and their indexes. So what you notice is the first one is dog. You can see 0 here. So that means the word dog is 0 index. That's the first word. Then we have flow. Then we have his. Then we have me. Then we have on and so on. So this is the vocabulary we will use. Now, let me take another code window. Let's now convert our input to this one. So for that, we can say vector. And I will say, okay, vectorizer dot transform. This is the method we use to convert our input into a matrix form. And then let's show you this. So I'm going to say print vector dot to array. This will give you an indication of what we have. So I don't know whether you can understand this one. Let me get back my slide, and then maybe we can one-to-one map and see. Give me a second. I got stuck. Hope you can see, right? So the second representation is we are going to focus on is called term frequency and inverse document frequency, right? Now, the difference from our simple bag of word representation that we have discussed earlier, it's simply we have a set of words and how many times it appears. We look at how important word in the document collection. So we have something called a weighting factor, and I will show you how we weight. And this is quite useful, and you will see that stop words will be removed. Now, remember, in previous one, you notice that you have more weight or word frequency indicates that stop words are important. And in this representation, automatically handles the stop words. I will show you the simpler version of TF-IDF, but in actual implementation, this is slightly different. So if you're interested, you can, search and understand. The simpler representation, there are two parts. As I told you, we have term frequency TF, and then we have document frequency. So simply, we have two products. We will multiply term frequency log n divided by document frequency. N is total number of documents. So let me elaborate the same. I'm going to use the same example, explain the idea of this and especially show you how it handles the stop words. So if you remember our metrics from our previous example, it looked like this. So in term frequency means exactly the same thing that we have discussed under backgrounds. So simply, this is the metrics, same metrics that we have seen in backgrounds. So simply you have all the, how should I say, the term frequencies that we have seen earlier in the bag of words. So we use that. That is TF. Second one is the document frequency, right? Remember, document frequency means how many documents contain each word. How many documents contain, right? So if you look at, let's start with the word dog, you can notice that it appears two times, in two documents, flow in two documents, his in one document, man in two documents, on in two documents, article the in three documents, right? So that's the document frequency, right? You got my point? Right. Now we have understood the term frequency, and we understood the document frequency. Inverse document frequency means we take log. If I go back again, let me go back again. We say log n divided by document frequency, right? That's what we have discussed. So we come here and let's take log number of documents, in our case 3, divide by token, document frequency. So if you here document frequency is 2, so I'm taking log 10 to the base 10, 3 divided by 2. So for example, if you go to, there's a word the here. So what happens? Log 10, 3 divided 3. Notice that here it will become 0. So ideally, if you are using this representation, you will notice that, that part, document frequency, especially inverse document frequency, will be 0 for stop words automatically. So in this method, it automatically removes any stop words, right? So I think, I hope you have understood the document frequency and the inverse document frequency. Simply, final one would be TF-IDF, means you multiply term frequencies with inverse document frequency value. So you can notice that these are the value, the second term, and note it here, there is 0. Because of that, when you multiply this with the term frequency, this is where you end up with. Yes, any question on this one? So our hand calculation will be slightly different from the actual implementation, because although we use log-based 10, if you take scikit-learn implementation, they have used one is natural logarithm for the log, and also they have uh, considered use of normalizing this, right? There are some situations where this weight will be undefined. So therefore, they have treated this slightly. So therefore, I will show you the code. You might not get the exact accuracy because it's slightly different from this simple, representation. So if you're interested, you can have a look at it. Right, now let me go back to the code again. So I'm going to discuss how we may use TF-IDF as well. Okay, right. Now that we have understood the use of this, let me explain how to make use of TF-IDF as well. So we have discussed bag of words, and here is the representation. So now I'm going to talk about how to use TF-IDF as well. Right. Simply, again, if you go to scikit-learn, it's called TF-IDF vectorizer, right? So this is the one actually we have slightly discussed how you may actually calculate this. I don't think there's an equation, but I told you like the equation that I showed is like it's slightly modified version of this. But the core principles are the same. Therefore, I'm going to make use of the same. So yeah, so we can say for sklearn dot feature extraction dot text import TF-IDF vectorizer. Right. And then let me use same input. So I'm going to use the same documents. And simply it will be the same code. If you look at here, vectorizer, count vectorizer. So let me copy paste the same and slightly modify. Instead of this, we will use TF-IDF vectorizer. Right. I don't know whether this part will work. Maybe run and see. Yes. vocabulary, it will be the same. So there's no change. The words are appeared. So now let's transform. So when you're transforming, you have to be careful because I'm going to use word at a time. So let me show you the vocabulary, and then maybe and you can notice the inverse document frequency is slightly different from what information we have calculated. There's a slight adjustments, so that's the reason why we are getting this one. Right, transformation document, let me show you. So we can use the same idea with vectorizer transform, but the input will be slightly different. Let me explain that one as well. So in this particular case, so we have to make the transformation. So if you just use input, and then if you say right, so you will get this is as the outcome in transforming our input documents as a TF IDF vector, right? So you can notice that. So this will transform into a matrix form, although the numbers will represent slightly different idea. And in this one also you can notice so here what I did, I'm explaining about the train set I have provided in the assignment, and I have uploaded the local directory, and then I have used pandas to read it. And this particular data set actually separated with the tab character, so I specify that. And I have given some names of the columns. So we have 4 columns. So the first one is class, then title, then date, then body. And when you take the head, which means the first 5 records from the data set, and this is how it looked like. Right. So let me explain the simple usage of this. Maybe you can take class and the body, and then you can work on a simple text classification problem. For example, can you confirm whether you have finished up to this point? Okay, so what we have done so far, I have shared with your training data set, and then the data set actually separate with the tab character. So that's why we have used separation tab character and provided the label for the 4 columns. And you can notice the first column is a class which consists of positive and negative, +1 and -1. Then you have titles for the news item, date, and then the body. Now, to consider or simplify the problem, we got the body as our text and the class as the labels. And in this part, what you notice is we are using count vectorizer, bag of words representation, and then we transform the text. And that's what you will notice. The next parts, you can customize the way you want. In my case, I simply build a decision tree model. I split the data set as 2/3 for the training and 1/3 for the testing. And we use the decision tree classifier. And then we have visualized it. And that's what you will see here. Right. Next thing is what I want you to do is work with this one, see whether you can get better accuracy with other classifiers. So, and this is what we are getting. So when I look at my accuracies, and this is how it look like. So we can notice that accuracy of this model using simple decision tree classifier without optimize anything, we get about 83% accuracy. Right. Last two, I think you can work on this one. See whether you can build a model. And then I have given you another data set, right? Without labels. I want you to figure it out how to figure it out the prediction for those labels for those, right? Actually, this is a very interesting problem. I didn't say that what are the two classes are. I'm expecting you to tell me what +1 is and what -1 is. Okay, before we finish today, let me discuss one more ideas. I want to discuss stemmers as well as lemmatizers. I already told you the stemmer means removing prefixes and suffixes from this. So for that, I will use NLTK stem. I will use import porter stemmer. Porter stemmer is actually a popular algorithm for removing prefixes and suffixes. And we can say and then let's try simple examples, right? I'm going to say, okay, print multiple values. Therefore, I will say, okay, PST dot, I'm going to use a stem method, eating, right? So when you say eating, it will remove ing and it will say, okay, eat. What about eats and eaten? You will notice that eats fine, it will remove s, but eaten, you notice that it couldn't just remove the prefix because nothing to remove from that. What about ate? Right? So you will notice here. So the stemming is a way of removing prefixes and suffixes. and to get the base word. And you will notice that the difficulty for the last two cases, eaten and ate, there's no way that you can remove prefix and suffix to get the base word. So let me share the code. Last one I want to discuss is lemmatizing. Right. Now, lemmatizer means like basically you are using a one-to-one mapping. And for that, actually, we will use something called WordNet, which is there are a set of tools developed with WordNet. So you can find the mapping. So we are going to use that one here. So therefore, the first thing is you have to import this. I will say import NLTK, and I will download WordNet. So this might take some time. And once you download, actually, you can use Lemmatizer for this one. Okay, go and confirm the multinomial is 97 and Run-of-Row 91. So multinomial is better, right? Of course, if you read the documentation, you will notice that multinomial 9 base is one of the popular classifiers in text classification problem. So I think it's good that you have realized this. And thanks, Diane, for sharing your findings. Okay, then, okay, now let me explain the final thing for today. I want to explain one last thing. This is called lemmatization. So this will be a one-to-one mapping using lemmatizer. So the code for this will be like you are actually using NLTK stem and import word lemmatizer. And then we will use word lemmatizer. I will use WM. And then I'm going to make use of same things that we have discussed earlier as well. Eating, eats, eaten, and eat. But together with, ideally, you have to use a word as well. Ideally, you can notice that we are not getting this correctly because we have to tell part of speech tagging, whether it's a verb, a noun, and so on. So I will add one more here. So ideally, we can say part of speech. B is actually representing the verb, and you will notice that this will appropriately map it to eat. So let me copy paste the same for other things, for eats, eaten, and ate. And you will notice that, so all the 4 cases in this one, it successfully identified the base form, that is eat. Right. So let me share with you the answer. Okay, so I think that's all what I have you for today, right? So simply we actually covered almost everything in the syllabus. Maybe I can talk a little bit more about data preparation and maybe a little bit on statistics. With that, we can conclude the course. As a assignment, I will put the deadline. Maybe hopefully you can spend about 4 weeks on this problem. Remember, so you have to predict the labels for the test set provided you without any labels. Right.